Now our topic is Poision distribution. The contents in this topic are introduction, applications of Poision distribution, constants of Poision distribution, and problems on PD, conclusion. Simply we call Poision distribution as PD. Okay. Now we see the Poision distribution. First, this Poision distribution is introduced by S.D. Poision. This Poision distribution has a rare distribution of rare events in he introduced 1837. So rare events, rare distribution means the events whose probability of occurrence is very small but number of trials are very large. See here the probability of events are very small but trials are very large. The number of trials as n is large and probability of success P is small here. Okay, success means required, favorable. Okay, generally here n is more than 100 like that. Here lambda is equal to np. What is lambda? Mean. Okay, lambda is mean here. Okay, Poisson distribution is a discrete variable. It is a discrete variable. Now we see the definition of Poisson distribution. A random variable x is said to follow a Poisson distribution. It assumes non-negative values and its probability density function is given by P probability of x, this one. P of x is equal to x. X may be 1, 2, 3, 4, 5 like that. Okay. This probability of variable x is equal to lambda power x e power minus lambda x factorial. Already we know lambda is np. It is mean. Okay, here lambda is mean. Here see here p of x occurrence and a probability of small x occurrence. Okay, next mean of success, mean and చెప్పాము. Lambda వచ్చేసి mean అని చెప్పాము. Okay, next x వచ్చేసి this symbol is factorial. Okay, this is formula, you remember it. By using Poisson distribution, the definition, probability of x is equal to x means 1, 2, 3, x is equal to 3. When x is equal to 3, find the probability అంటారు అంటే x place లో 3 పెడతాం. So if we know lambda value, mean of this Poisson distribution, we know mean of the Poisson distribution, then we can find for each x the probability. Next, we apply this Poisson distribution in so many fields. See this one, the count of alpha particles emitted per unit of time is useful in analysis of any radioactivity substance. We know in radioactivity substances, minute by minute, that particles are increasing very high, very large, up to infinity also. So, these large cases, we use the Poisson distribution. Next one, the number of telephone calls received at a given switchboard per small unit of time. Small unit of time in telephone department, so many calls are received. Next, number of deaths per day or week due to a rare disease in a big hospital. See, nowadays corona is a very big disease. It is a rare disease. In corporate hospitals, there are so many death cases per week or per month. Okay, in that case also we use the Poisson distribution. Now we see the constants of Poisson distribution. Constants means mean, mode, like that. Now see this one, mean definition or symbol is mean symbol is e of x. Expected value is called as mean. We already know this symbol. But for Poisson distribution, this mean is defined as sigma x into px and a variable into its probability. Now x into, what is p of x? By definition of Poisson distribution, probability of x using the Poisson distribution, probability of x is e power minus lambda power x factorial. You see x here is, x is there, here x factorial means x into x minus 1 factorial. Cancel x, in denominator you have x minus 1. and sigma for x values. Bring out this e power minus lambda outside the sigma. X factorial is x into x minus 1 factorial. Already I told. Okay, e power minus lambda, bring this side. Cancel this x. You get x minus 1 factorial here. In numerator we have lambda x. Put x is equal to y. See here, x is equal to 0. 0 the start of term. But x minus 1 undi kabatti ikkada x 0 పెడితే -1 వస్తుంది. There is no factorial for minus values. కాబట్టి x is equal to 1 తో ఒక x పోయిందమ్మా క్యాన్సిలేషన్లో. సో 0 టర్మ్ తీసేసామని అర్థం. x is equal to 1 తో స్టార్ట్ అవుతుంది. సో x minus 1 0 అవుతుంది అనమాట. Put x minus 1 is y. Then we get this e power x. What is it? E of x. Put x minus 1 is y. You get here y factorial. Here lambda x minus 1 y అయితే x is equal to y plus 1 అవుతుంది. Y is equal to 0 to infinity. So y is equal to 0 to infinity. Y factorial and numerator is lambda power y plus 1. You see here ma, lambda y into lambda. You write it as lambda y into lambda. Bring lambda outside. Sigma lambda power y by y factorial y 0 to infinity. But this value is, the sum of this value is e power lambda by some formula. This is e power lambda. Now e power minus lambda, e power lambda cancel. We get lambda. So expected value, mean is lambda. Mean is lambda and this lambda value is NP. Already we have seen in the definition. So the first constant of Poisson distribution is mean and it is equal to lambda, which is equal to NP. Mean is lambda here. Mean is lambda. You remember that. The next one is variance of Poisson distribution. Variance symbol is V of x and it is e of x square minus e of x whole square. We know that e of x is mu. So the last term, second term is mu square. Mu square. What is e of x? Sigma x into p of x. But e of x square ante here x square. So e of x square is sigma x square p of x. X is 0 to infinity and this term is already e of x is lambda square. Here mean is lambda. Kabatti lambda square. In binomial distribution mean symbol is mu anamata akkada. Ikkada e of x value, mean value lambda kabatti put lambda square here. Now this is x square p of x. Now substitute p of x value. What you get? X square as it is, sigma as it is, last term as it is. P of x is e power minus x lambda x by x factorial. Here x factorial means x into x minus 1. Okay, x cancel పోతుందమ్మా ఇక్కడ. ఒక x cancel పోతుంది. Okay, you see here v of x is equal to ఒక x cancel పోతే ఇంకో x ఉంటుంది. కింద x cancel పోతే x factorial లో x minus 1 factorial అవుతుంది. As it is last term. Okay, now this is e power minus lambda sigma. This x can be written as x minus 1 plus 1. X, for our convenience we take it as x minus 1 plus 1. Lambda power x by x minus 1 factorial minus lambda square. I'll consider this as two terms. X minus 1 into this one. Sigma x minus 1 into this term plus e power x for both of this term. Treat x minus 1 as one term and 1 is other term. Okay, e power minus lambda common. Sigma x minus 1 into this term, this one, minus sigma 1 into this term as it is last term. So you cancel this x minus 1 here. Cancel this x minus 1 in the first term. You get x minus 2 factorial is there. And the last term as it is. Sorry, second term as it is in the bracket, last term as it is. You get like this. Put x, y is equal to x minus 2. X minus 2 means this is y factorial. And this one is, what is x? Y plus 2. So you get this term x power, x means y plus 2. Lambda power y plus 2 by y factorial. And x minus 1 is z. This is x is equal to z plus 1. Lambda power z plus 1 by z factorial. Like this. You write it as lambda power y into lambda square. Lambda square, ముందు పెట్టేసేయండి. లాంబ్డా పవర్ బై వై ఫ్యాక్టోరియల్ ఈ పవర్ లాంబ్డా అవుతుంది. అలాగే ఇక్కడ లాంబ్డా పవర్ జెడ్ ఇంటూ లాంబ్డా, లాంబ్డా సిగ్మా ముందు పెడితే లాంబ్డా బై లాంబ్డా ఇంటూ సిగ్మా లాంబ్డా పవర్ జెడ్ బై జెడ్ ఫ్యాక్టోరియల్ వస్తుంది. ఇలా లాంబ్డా స్క్వేర్ పక్కన పెట్టేస్తే యూ గెట్ దిస్ వన్, లాంబ్డా పక్కన పెడితే యూ గెట్ దిస్ వన్. బట్ వీ నో దిస్ సమ్ ఇన్ ఎనీ వేరియబుల్. ఇప్పుడు సిగ్మా y is equal to 0 to infinity lambda power y by y factorial gives e power lambda. Lambda ప్లస్ లో z ఉందంటే సేమ్ లిమిట్స్, సేమ్ సమ్మేషన్, సేమ్ పవర్, జస్ట్ y ప్లస్ లో z ఉందంటే ఏ వేరియబుల్ అయినా ఉండొచ్చు కదా. నౌ దిస్ ఈజ్ ఆల్సో e పవర్ lambda. నౌ యూ సీ ద ఫస్ట్ టర్మ్ lambda square e power lambda plus second term lambda e power minus lambda, last term as it is. Now e power minus lambda into this one you gives lambda square. E power minus lambda into this one gives lambda. Okay, this first term lambda square plus second term lambda minus lambda square already is there. Cancel lambda square you get lambda. So variance is equal to lambda. Now you observe this is very special for the Poisson distribution. Mean is lambda and variance is also lambda. Only for the Poisson distribution we have mean equal to variance. You remember that. So variance of distribution is equal to mean of distribution, which is lambda. Now what is SD? SD is the root of variance. Now we have SD sigma is equal to root lambda. Root lambda. Now we have finished the two constants of PD, which are mean and variance. Now mode. What is mode? By definition of mode, mode is the value of x for which the probability p of x is maximum. For which p of x is maximum. A variable kaite probability maximum untundo, that variable value is treated as mode. Mode is the value of x for which the probability p of x is maximum. Okay, and ఇప్పుడు p of x maximum నేను x mode అనుకుంటున్నాను. I am taking x is mode, p of x is maximum అంటే p of x plus 1 కంటే ఎక్కువ ఉండాలి, p of x minus 1 కంటే ఎక్కువ ఉండాలి. x వాల్యూ కంటే పెద్దదైనా చిన్నదైనా ఏ వాల్యూకైనా సరే ఇది p of x maximum అయి ఉండాలి. సో p of x is maximum కాబట్టి x is mode అంటున్నా. I am taking x is mode of the SD, Poisson distribution PD. Now we have probability of x is maximum for probability of all other variables. So p of x greater than or equal to p of x plus 1. And also p of x greater than or equal to p of x minus 1. p of x అనేది ఏ వేరియబుల్ కైనా కూడా ప్రాబిలిటీ కంటే కూడా ఎక్కువ ఉంటుంది. ఓకే, p of x maximum వాల్యూ కాబట్టి p of x greater than p of x plus 1 and p of x greater than p of x minus 1. Now first we take p of x greater than p of x plus 1. Use the definition. P of x is e power minus lambda lambda power x by x factorial, and p of x plus 1 is e power minus lambda. It is standard amount. E power minus lambda. In place of x you put at p of x unte lambda power x x factorial. P of x plus 1 unte lambda power x plus 1 factorial. రెండు సెట్స్ e power minus lambda cancel అవుతుంది. x plus 1 lambda x plus 1 factorial means x factorial into x plus 1. కాబట్టి x factorial cancel అయ్యి ఇక్కడ x plus 1 మిగులుతుంది. ఇక్కడ lambda x cancel అయితే lambda మిగులుతుంది. Then you get here 1 e power minus lambda cancel, ఇక్కడ x factorial cancel, lambda power x cancel, 1 is there. ఇక్కడ ఇది cancel అయింది, ఇక్కడ lambda x cancel అయితే lambda ఉంది, ఇక్కడ x plus 1 ఉంది. కాబట్టి here 1 greater than or equal to lambda by x plus 1. రివర్స్లో రాస్తే lambda by x plus 1 less than or equal to 1. So lambda less than or equal to x plus 1 or x plus 1 greater than or equal to lambda. So x, from this you write x 1, bring this side, x greater than or equal to lambda minus 1. Put equation number 1. Next let the second part. What is second part? This one. P of x greater than or equal to P of x minus 1. From the above case we have P of x greater than or equal to P of x plus 1 ki x greater than x plus 1 greater than 1 వచ్చింది. ఇప్పుడు P of x greater than or equal to x minus 1, P of x minus 1 తీసుకుంటే x greater than or equal to x less than or equal to lambda. You get x less than or equal to lambda. Now you observe from this you write lambda minus 1 less than or equal to x. lambda minus 1 less than or equal to x, that x less than or equal to lambda. So from 1 and 2 we have lambda minus 1 less than or equal to x less than or equal to lambda. So mode of Poisson distribution lies between the x value is we say x value is the mode of the Poisson distribution when p of x is maximum. మనం p of x maximum అని తీసుకొని స్టార్ట్ చేసాం కాబట్టి this x value is mode. This x value is mode. This mode lies between lambda minus 1 and lambda. So mode of the Poisson distribution always lies between lambda minus 1 and lambda. So this is the mode condition. Next we see the recurrence relation for PD. PD means Poisson distribution. We have by definition p of x is e power minus lambda into lambda power x by x factorial. Now what is p of x plus 1? In place of x, both sides you put x plus 1. We get p of x plus 1 is there, RHS e power minus lambda lambda power x plus 1 by x plus 1 factorial. That is equal to e power minus lambda into lambda power x by lambda power x into lambda. కాబట్టి numerator lambda into lambda power x. I am taking lambda into e power minus lambda x lambda power x, and denominator x into x factorial into x plus 1. So x factorial into x plus 1. Now it can be written as p of x. It can be written as p of x. Now lambda by x plus 1 into p of x. Now we know that p of x is equal to lambda by x into, similarly p of x plus 1 is finally p of x into lambda by x plus 1. ఓకే, ఇక్కడ రెండు పక్కల x ప్లస్ x మైనస్ 1 పెట్టండి. రెండు పక్కల x ప్లస్ x మైనస్ 1 పెడితే p of x minus 1 plus 1 is p of x, and here lambda by ఇక్కడ x plus x minus 1 పెట్టాలి. x minus 1 plus 1 means x, p of x minus 1. So what is the recurrence relation? p of x is equal to lambda by x, p of x minus 1. Then the next value p of x plus 1 is lambda by x plus 1 p of x. Then the next value, recurrence relation means continuation. p of x plus 2 is lambda by x plus 2 p of x plus 1, like that. Okay, this is recurrence relation. p of x is equal to lambda by x, p of x minus 1. For example, p of 2 lambda by 2 p of 1, p of 3 lambda by x, p of 2, p of 4 ఇక్కడ p of 3 వస్తుంది. అంటే దాని ప్రీవియస్ వాల్యూస్ యూజ్ చేసుకొని రాయడాన్ని రికరెన్స్ రిలేషన్ అంటారు. సో వీ హ్యావ్ సీన్ ఇన్ దిస్ distribution, Poisson distribution, we have seen the constants of PD. What are the constants? Mean is nothing but lambda. Next, variance of PD. Variance is nothing but lambda. Both are same. And mode. The mode lambda. The mode is x lies between lambda minus 1 and lambda. And the recurrence relation of Poisson distribution is p of x is equal to lambda by x, p of x minus 1. This is the Poisson distribution. This is the recurrence relation of PD. Recurrence relation is nothing but use this px, find the next value. P of x plus 1 is lambda by x plus 1 p of x. If you know p of x, then you can easily find p of x plus 1 using this p of x. Next, p of x plus 2 is equal to lambda by x plus 2 p of x plus 1. అంటే ముందు వాల్యూ యూస్ చేసుకొని నెక్స్ట్ వాల్యూ ఫైండ్ అవుట్ చేయడమే రికరెన్స్ రిలేషన్. ఓకే, దిస్ ఈస్ ద రిక్వైర్డ్ formula, recurrence relation, which is called recurrence relation. Then we see the problems. These are the constants of Poisson distributions.